Audio check.
Yeah, we can see your slides and we can see you. That's great. And we're also on the top of the hour, so maybe let's get started already. Hi, everybody. Welcome to the Transport Services Working Group. It's good to see everybody on site or online. Those who are on site, please remember to join Mideco to sign the blue sheets and join the mic queue. Using the full version of Mideco will give you access to the chat as well. Also, I don't see anybody sitting towards the back of the room, but I hear the acoustics are kind of better at the front, if that's an issue. Reminder that this meeting is being recorded. And by the way, my name is Reese Enghart. I go by Teresa in the data tracker and various systems. My co-chair, Aaron Falk, is joining us remotely. And without further ado, I will pass it to him for these chairs updates.
Hello, everybody. Can you hear me?
You're a little bit quiet, actually. If you can turn it up a little bit,
I'll do what I can. Changing
at
the
least
mic volume.
from here.
I'll try to speak more forcefully.
Thanks.
Okay. So, hi, I'm Aaron Falk. I recognize some of you in the very tiny window present in Vienna. Glad you guys were able to make it. Note well, anything that you say here is considered an IETF contribution. You've probably seen this multiple times. IETF meeting tips. Hopefully you've seen this as well, especially those folks who are on site. Please use the Meet Echo Lite client to get access to the mic queue and turn off your audio and video if you are not on site. And oh, I see I should be using a headset. Well, I couldn't pair my headset, so I'll have to muddle through with that. But it's a short presentation and nothing too controversial here, I think. Today's agenda. So we are almost halfway through the chairs update, so we're already making progress on the agenda. Tommy's going to talk about the quick mapping document. Thorben's going to talk about a new quick implementation, Pan API. We have some time for open mic, and that's the plan for today. And please note that there's video taken of this session. It will be recorded and available for later viewing. Okay, a few updates on what's been happening. So since IETF 111, which was some time ago, we've had 6 interim meetings. We're trying to meet basically once a month. 2 of our 3 main docs, the architecture document and the API document, have received reviews from the art reviews and sector, as well as some internal deep reviews. Working group's been focusing on resolving those review comments, which were plentiful, and we're grateful for getting that kind of external review. And we've been focusing naturally on getting the 3rd document, the implementation draft, ready for working group last call. The last item to point out was these documents had have many contributors, and the author list had grown quite long. It violated the recommendation of 5 authors for an RFC. The chairs and the authors discussed this at length. Some of the contributors, the smaller contributors, elected to remove their name from the author list. We're still, I think, at 7 authors on one document and 5 for the other 2. These are all significant contributors. We've got a justification written for that when we submit this to the IESG, and I feel really good about where this is right now. I'm hoping that it doesn't become a problem for publishing the docs. And naturally, our area director is up to date on some specifics on the documents themselves. The architecture document has concluded a working group last call, and that included a bunch of deep reviews and external reviews. The interface document in the same state. There's still not all the issues are resolved, but we're down to only two, which is awesome. And the implementation draft is, I think, not quite there yet. There's still a handful of open issues, but there. My assertion, and I think the current plan is to take this document to working group last call after the IETF. We'll see if there's any discussion of that when I'm through with these slides or during um, the open mic time at the end. One thing that we'd like to do is see if we can get some non-authors committed to doing a thorough review of the document during the working group last call. And so I guess I should pause here to see if anybody would like to sign up to take that on. I think we've found that it's been useful for sort of editorial continuity and consistency with the other documents and just general quality. So my view of the room, maybe if anybody is interested in taking that on, you could just join the queue. It's fascinating reading, I promise you. Zad, let's see, do I have to push something so Zad can talk? I think I do.
Hello. So first of two things. First of all, thanks for resolving the author list issue. I mean, we have really worked really well together as a team to resolve that. So I really appreciate all the authors and the chairs to actually helping on that one. So on this jointly submit jointly together. I mean, we can do that. Do you see any point of those who completed working last call to go for IETF last call, write the Shepherd document and edit reviews and everything done separately and then go for IG evaluation together? Is there any point of doing that? I'm
Well,
just
the
trying to
reason
see
that
like
we
whether I can distribute my workload.
the reason that we elected to hold the first document was that we were there's a these documents have a lot of abstraction in them, and we wanted to get the wording consistent between them. And in fact, we've made a bunch of sort of search and replace changes to get the wording, some of the terminology to be consistent. So I would. Um, I would, I guess, once we get it through a last, maybe working group last call, I guess we could probably release the first two to IETF. I can't remember the ordering, whether it's IESG or IETF. So, but
IETF, yes.
It takes you as long to review them as it takes to review them. I mean, we've been working on these documents for like 7 years. So if you can spread out the workload in whatever way makes sense to you. That's the burden of being an AD.
No. So it makes sense to me just to if we are completing the working last call for tabs, arc, and interface, let's put them forward, and then we can also have another pass of these issues when in the IETF last call. We don't know what we are getting there, so that might actually help implementation document actually to align with the terminologies and everything that anything we need to change. So just a thought. I mean, I'm not suggesting. I don't have any extra opinion on that one, but think about it.
Yeah.
If we can do
Okay.
that.
Okay. Yep. Thank you.
All right, so I'm actually curious who has read the implementation draft. So I'm going to see what a show of hands tool gives us in a hybrid setting. So I guess people can also raise their hands physically, but it's kind of interesting. I think the presenter laptop can also raise its hand. Let's say within the past 3 versions. So we have 7 raised hands and nobody is raising their hand in the room physically. Okay, 8. Okay, that's good. All right, let's end that. So, do we have anybody who can do a sort of more extensive review of this document in working group last call who is not an author?
I think that just to level set here, that the criteria for this reviewer, you don't need to be an expert, right? We're asking for people who are non-authors. We're looking for readability, consistency, comprehension, stuff that people who are really familiar with the content are probably going to miss. So if you have not been deeply involved in the past, that does not disqualify. In fact, that probably makes you a better candidate for a reviewer. All right, seeing no volunteers, we'll take this to the mailing list, see if we can beat up some volunteer cycles.
So there is one, hi, Brian Dremel. There is a question from Thorben Krieger in the chat about when we need this review completed by, which I'm bringing to the mic because that might be input to whether or not.
Yeah, thank you. I would say ideally 4 weeks after IETF, probably roughly the time for our next interim. But I think um, if we have somebody who would be willing if they had a little more time, um, it, I'd rather have a volunteer who needed more time than have to waste that potential review time finding another volunteer. So. Okay, well, let's move on. You don't need to, if you think about it, you can contact Reese or myself. Okay, Thorben is thinking about it. Thank you, Thorben. Moving right along. Okay, so a slightly revised schedule. You can see we are here on the left. The general plan for the working group, our cadence has been to try to have an interim every month. We usually meet for 2 hours and go over, get issues and pull requests. If we can get the review done by April, we'll have a working group last call open then. And then really the interims will continue until we resolve the working group last call comments. Our general cadence, we actually, I think, got a consensus, maybe it was in one of our interims, that meeting every IETF didn't seem like it was going to be a great use of our time. Most of our the interim meetings are quite detailed and don't necessarily lend themselves to sort of a cross participation. And so we arranged this meeting because we agreed to meet every other IETF. So if we continue on that, then we would not meet at IETF 114, continue on with our interims, and then meet at IETF 115. Let me just pause here. People have not seen this before, so if anybody has any comments on it or questions, we can talk about that now. Okay. So, and then the final slide here is, we have talked about mappings, which for those of you who aren't closely involved in TAPS, TAPS is a generic API for accessing services provided by transport protocols. And we thought that it might be useful to produce some documents that showed how a protocol that sat on top of TAPS, whether it's a transport protocol or any other, would make use of the API and Tommy's going to talk in a few minutes about Quick for that. The general feeling has been, you shouldn't have to have a published mapping document to use TAPS, but this is more of a matter to make it easier for folks to understand how they would make use of TAPS if it was available for them. So the proposal here is to add a milestone for producing a protocol or one or more protocol mapping documents to our charter. We need our area director's approval for this. I'm raising it here in case anybody has any comments on it. We're going to chat with Zayed after the IETF on it. Certainly, any comments on the value of the quick mapping that Tommy's going to be talking about will inform that discussion, and also whether there are other candidates. And I think that a candidate in my mind would be a protocol where it's not obvious how you would use TAPS to get what you want, or maybe there are benefits from using TAPS that would not be obvious to the upper layer protocol. And so it would be sort of a collaborative activity between somebody that has some expertise in the upper layer protocol and folks in the TAPS working group. Otherwise, why do it in the working group? So let me just pause here, see if there's any questions or comments on this, or any objections to doing this. Okay, there's a comment from Martin on the chat that HTTP is one where the mapping is pretty unclear.
And I saw a thumbs up to the slide, which
Oh,
multiple.
excellent. Thank you.
Two.
I think we can probably find some HTTP expertise within the IETF. Okay, so that's it for me. Thanks, everybody. Sorry I can't be with you. And let me hand the baton back to Reese, if I can figure out how.
Thanks, Aaron. All right. So I think next up we have our presentation on the quick mapping. So if Tommy could join and share the preloaded slides, please. Hi, Tommy.
Hello. Hey,
Good
everyone.
to
All
see
right.
you.
Pull up the slides. Okay. Everyone can see this?
Yes.
All right. So I'll be sharing a document which I only put out at the beginning of this week. So after the deadline, there was a previous document from a couple of years ago where we talked about how you could use TAPS as an API for Quick, and it gave a couple different options. That was before we had a lot of the formal mapping concepts within TAPS implementation. And it was also when Quick was very much in flux. So this is a simpler, more direct document that hopefully will be useful as both an example of how we can do a mapping, as well as just showing how we can use TAPS with Quick. All right, so what is a TAPS mapping? So if you have read the implementation document, you should be familiar with this, but as we see, most people have not read that in detail. There's a section at the end of the document with a bunch of mappings for the transport protocols that were originally analyzed within TAPS for TCP and UDP and SCTP. But essentially what these are just definitions of what happens when you use each one of the transport services API calls and a different transport protocol is loaded underneath. So it's very implementation focused as far as, if you're building this API, how do you actually wire it up into the individual protocol calls? And it also tells you as an API adopter what the contract and guarantees are when you are using the TAPS interface. And this is really focused on kind of the establishment, teardown, and data transfer properties. There are a lot of other knobs within the TAPS API that aren't really transport specific. They may just be about path selection or something else. So not every API surface shows up in the mapping. And from the implementation document, we have an appendix in there which says, here are the things you need to add or need to define in a mapping document like this one. And so it has a template. And so this is essentially the first document that's trying to follow this template and show how we can extend it. And as part of the exercise of doing this, I realized that we needed to update the template a bit. We have relatively recently added some close group and abort group functions to the overall API to handle tearing down multiplexed connections or groups of connections in general. And when we added that to the API, it didn't make it into the implementation document. And so we actually already have merged in a PR to update that. And so that was one thing, that's good about actually using this template and exercising the mapping, is that we learn any things we were missing. So it's a good part of the review of the implementation. All right. So going into this particular document, it's very short. You could read it in, a couple minutes. It's mainly trying to copy the style that we have in the implementation document for TCP, UDP, and SCTP. The particular approach for what the mapping is based on our experience within the network framework at Apple, since that is a TAPS-like API and it supports Quick. And originally we had various different approaches we were trying. This mapping reflects what we ended up shipping as our Quick API, and because it ended up being the most friendly for use on top of a TAPS type abstraction. One thing I would point out is that there doesn't have to be just one mapping for a given transport protocol. The one here that is defined in this document currently is just about Quick streams and how to use unidirectional or bidirectional streams within Quick. It doesn't currently address how you use datagrams, and it's possible that you would essentially have a different mapping for accessing unreliable data on Quick than you would for the reliable streams. Or you could have it as one. So there could be a broader zoo of mappings that gets defined for different use cases, and I think that is okay. And as I mentioned before, building these mappings is a good way to exercise the API functions and make sure that we handle multiplexing protocols well. All right. So the first part of a mapping is just to define what are the objects at the high level, what are they mapped to, what is the overall contract of this, and there are a couple different options. So first we have to define what is your connectedness of, like, is this an unconnected like UDP? Is it connected like TCP, or is it an inherently multiplexing protocol? So Quick is inherently a multiplexing protocol, so it gets that connectedness. The mapping also wants you to define kind of what's your basic data unit offered by this transport. And so in this case, it is a byte stream. And that's why this mapping is specifically applying to using Quick streams and not Quick datagrams. That would need a different mapping. And then the last thing here is, what is the connection object? And this is probably the most interesting, confusing, controversial choice here. This is like the main thing to choose. And this mapping defines that a TAPS connection, which is the thing that you're used to using as a TCP stream, like the equivalent of that is a quick stream, which makes sense. Like when you're just calling, like I need an object on which I can create one and send and receive a stream and get to the end of a stream. That's the semantics of a quick stream, not a whole quick connection, because a quick connection really maps to what in TAPS is a connection group. It's a bundle of streams that all work together. And then the rest of the mapping, this is not literally what's in the text. The text goes into more detail, but just at a high level to summarize what you see, these are some of the interesting bits. So calling initiate on a connection will, because this is a quick stream, if there's not already a quick connection to the peer, it will have to bring that up. But if there already is, initiate really just is allocating a new stream ID on which to send. So it's either bring up quick connection and allocate a stream ID, or just allocate a stream ID on an existing connection. Cloning means you already had one existing stream, so you by definition had a quick connection established to the peer. So it is always by definition just allocating a new stream ID. An interesting thing here is that the connection becoming ready, which means that you're able to actually send and receive on it, is a function of both the actual underlying quick connections handshake completing, as well as having enough stream IDs available that you can allocate this new stream ID. So that could be delayed by streams being blocked due to stream flow control. So ready tells you, yes, if this is the 100th stream you've opened, you're allowed to now open that 100th stream. The listen and connection received calls mean that you have a new stream from the peer. For sending and receiving, it's quite straightforward and simple. Sending just generates stream frames on the quick connection for that stream ID. Receiving is handling the inbound stream frames that you get for your stream ID. Closing the connection is equivalent to sending a fin on that stream, just as it is with TCP. Aborting is sending a reset stream. Closing a group means that you close that stream and then you close the connection once all streams have closed. And aborting a group means that you immediately close the connection and you just drop all outstanding streams. So that's what is written in the document. I think it's the most straightforward mapping to quick from what we have in the TAPS concepts. But I'd love to hear thoughts or reviews on that.
Yeah, so we have Aaron in the queue.
Oh, sorry. I was not watching the queue.
Thanks,
Aaron.
Tommy. Your audio is gating a lot. I don't know if there's may want to turn off your video or something because it was distorting a bit. It might be some
sorry. I can turn off the video. Yeah.
We'll see if that helps. So I was looking for, I just scanned the document for the comments that you opened with about sort of the use cases for quick that that this mapping addressed that might help distinguish it from other use cases that might go to another mapping. And I didn't see that, and I thought that maybe that would be a good addition to the document. The just even maybe sort of a high level summary of what is this good for and what is it not good for, to help people sort of understand where they are in the zoo.
Yeah, that's a good point, and hopefully my audio is a little better now.
Yes, it is. Thank you.
Good. One of the things, so yes, it doesn't have a lot of descriptive text, but an option is that we could also add the quick datagram mapping into this same document as well, and then essentially say here are two different mappings for quick, and then have some text to couch them, and like this is when you use one, this is when you use the other. So that's, if people think that makes sense, that's a direction this could take.
Thanks. Next we have Brian.
Hi, Tommy. Thanks for being up so early to do this. Could we go back actually to the sort of the mapping bit? Yes. So I see sort of what happens if there's like create a new connection if needed. So that's a quick connection, right? So I get the mapping between connections
Right.
and streams, but there's one thing here that seems to be missing, and I'm wondering if that's like at a lower level of abstraction that we want to expose through quick. How does this interact with 0RTT?
Um,
Is there anything that we need to say in the
so
mapping about
it
0RTT?
is, yes, it is mentioned. So this is not exhaustive. This is
Okay.
what fit on the slide and was interesting. There is an initiate with send that essentially says this is the same as initiate, except
Right.
if you're bringing
Yeah,
up a new
initiate with send.
connection
Got it,
and
got
you
it,
have
got it.
zero
Okay.
RTT
Okay.
keys, use it.
Okay, good. Thanks.
Thank you.
Next, Lucas.
Hello. Sorry. Hello, Lucas Badu at Cloudflare. Thanks for the draft, Tommy. I had a quick read over lunch.
Good.
The thing that struck me immediately was like the lack of datagram here. I think given the progress that Quick Working Group is making on datagram, if you're going to do a mapping, just consider datagrams and streams. Like those are the things that applications can use. So just do it as one.
Mhm.
Contrary to Aaron's suggestion, it doesn't seem like we need to say what you would use them for. Quick doesn't. It just says this is the service that those things provide, and leaves it up to other people to decide how to use them. We might be documenting that elsewhere, and we could just point at that, but I don't feel like TAPS needs to say anything in particular. And then one specific point on the draft, I didn't see anything about stop sending frames for like how to cancel the one end of a stream. I don't know if that was in consideration at all, or just didn't make it into this cut.
Yep. Yeah, thank you. So yeah, on the point of including datagram and the reasons. So yes, I think to be complete, this needs to include datagram. And I agree with you that we shouldn't go into too much detail about the applications, but having a bit of text of, hey, if you're using TAPS to get a byte stream, then you should use the stream mapping. If you're doing it to kind of replace your UDP usage, use datagram. We could have some high level bits like that. As far as stop sending, this is something we have talked about previously in the group, and I don't quite remember, but I believe the consensus was it's not something that is included in the base API for TAPS because it is a feature that pretty much no other transport protocol offers on its stream. Like within Network Framework itself, we don't have an API to do it. It's not something. I guess it'd be good to understand, kind of at an application level, when is it needed, and if we believe it's generic. Because the other option is that TAPS APIs certainly do allow you to add protocol specific extra functions if you want to support that in your implementation, but it's not something that you can expect that every byte stream protocol would be able to support.
Okay. I don't know enough about TAPS. It just seems like a pretty critical thing for Quick to be able to do that, because you can't stop things otherwise. You can only close your side. So, but we can follow
Well,
up.
you can always reset the stream, right? Like, I mean, resetting the stream can be interpreted as it can also, like, the underlying level can do a stop sending as part of that if it needs to.
Okay. Let's take it offline. But thanks for this work. Cheers.
Thank you.
Thanks, Lucas. Next, we have Jonathan.
Hello, Jonathan Lennox. I guess my question, having only briefly read this document and not thought about it terribly hard, is this API sufficient to implement a fully fledged H3 client and H3 server? Or are there things that if you were actually doing that, you would need to do something magic. And maybe in Network Framework, you've actually done this, concretely, or maybe you can just think about it. But I guess my question is this, because I think that's where the rubber meets the road for, is this a complete API for Quick, or are there things that this doesn't cover?
Yeah, so we definitely have built H3 on top of this. There are, I think the one thing that is used there that's not explicitly part of this mapping is what TAPS would consider like a protocol specific metadata to access the stream ID numbers, et cetera, from within the transport. But so maybe that is something that would be good to add to the document of saying, hey, and you also probably want to expose a quick specific getter for your stream ID. But beyond that, this mapping for actually just using send and receive, create and close all work fine for H3.
Thanks. Next we have Martin.
Martin Duke, Google. Thanks for this. I've been waiting for it, and I support adoption. Not that we're asking for adoption yet, but let me preemptively do that. Just a couple of nits, like on the abort call, it should be like reset stream and/or stop sending, depending on directionality of the stream. And like on the listen thing, it seems to like say, well, open a socket, but in fact, listen is being used for receptiveness to new streams as well, correct? But conceptually, is that accurate, or?
Yes, it is. It is. Yeah, so we can clarify that.
Okay, thanks.
Next, Brian.
Hi, Brian Trammell, Google. I'll be brief because I think we're getting ready to go down a rabbit hole here. I would point out on the quick datagram thing, datagram looks kind of like sock-seek packet, which does exist in another protocol. So I think that we can sort of like, take some of how we've thought about SCTP into that. And I think it is probably important to do, right? Like, so we said we're going to do the quick base protocol, but datagram is rapidly progressing through quick. But I think these are things that we can do once it is, a working group item. Look forward to working on it. Since we're not talking about supporting adoption yet, I support adoption.
Cool. I mean, the last slide does say, should we adopt this? So that is a useful question to answer.
Okay, next, Colin.
Hi, can you hear me?
Yes.
Mhm.
Yes. Okay, good. So I guess I'm going to say something similar to what Brian started out with. I can see how this can be a replacement for a bunch of TCP connections very, very easily. I can also see how we can define this in a way that acts as a replacement for UDP and provides security and all that on top of it. Are we flexible enough in the way we've defined taps that we can ask for a connection which allows you to do both reliable and unreliable data on the same connection? So you can have data along streams.
Right. I think that's where kind of what the mapping of connection objects turns into in Quick is very important. So I think the answer to your question is yes, a TAPS connection group, which maps to a actual quick connection association between these two endpoints, can include both bidirectional streams, unidirectional streams, and datagrams, each of which would be a different TAPS connection object to represent that particular flow and that particular contract.
Right.
So you
so
could
we open it as an unreliable connection to the same endpoint. Yeah.
Exactly.
Yeah. Okay.
Thanks. And we have Michael, and after that, queue is closed.
Michael Wölzel. I wonder if these tool things that were brought up regarding the interface and Quick, if they, I mean, I don't want to make things harder for the interface document now for sure, but if they maybe should be included there, because I think the stop sending frame is probably safe enough to ignore for transports that don't support that. And the stream ID, I remember we had a conversation about that in the context of SCTP because that also offers it, but we didn't see that there's a need to expose that if people are associating semantics with the number of the stream. But I think that's also pretty easy to include as saying, it could be metadata going on the connection if it's a stream multiplexing transport. So I think we should probably include that in the interface draft, but I'm asking that question.
I would lean towards saying that, for sure in the mapping document, we should call out, you should have a way to access the stream ID. And we should review the interface document to make sure that it's clear, essentially, what function you use to say, get me the protocol specific information for this. Because, the specific type of a stream ID or one of these things could vary between different protocols. So there should just be a way to say, like, for quick, get me this property. And then you say, oh, I want, quick property stream ID, and then it returns me an object which happens to be varant in this case. Yeah.
Okay, yes.
Okay, and we have Zahid.
Zahid, transport AD hat off. I have one comment. So we used to have like those are RFCs now. We have the survey document and the feature document, right? We surveyed a couple of transport protocols and also the transport features and recorded them. So I think it would be good to have this kind of mapping document also to actually have some sort of like background information and the surveys around it, not just like direct mapping. I didn't find it this time. It would be good because some of the topics that I think Lucas was mentioning could come up here, and we could have a resolution in this kind of mapping document how to deal with those instead of like fiddling around already like long big documents. So that's one comment I have. Think about it, and that's the suggestion. With my Eddie hat on, I don't find this as a related document in the data tracker. So something went wrong. So maybe we need to fix that. Yeah, I think the naming of the draft didn't allow it to record as a related document in the data tracker. So maybe resubmit it with drafts. Tommy probably taps something.
Well,
Yeah.
you should be able to, the chair should be able to relate it directly as well.
Yeah, that's also true.
Okay, I'll look into that. Thank you, Zahid. And at this point, I'm curious to just get a sense of the room for the first question on Tommy's slide, which is support for adopting this mapping document. Okay, we have 21 raised hands in Meet Echo, 25. Oh, wow. And no physical raised hands. I guess Meet Echo wins. Okay, that's not bad. Thank you. So, Tommy, is there? Oh, yeah. Should we start others? Is actually the second question on this slide. We kind of have 2 minutes, and then we have another presentation with 15 minutes allocated. So maybe we can take this offline, unless Brian has something urgent, because we do have 2 minutes.
Brian Trammell, Google, no, not yet. Let's do this one first.
I agree.
So chairs, Eddie interruption again. I mean, two things. One, if there's anybody in this room who has not really used this online site tool or some way to log into this session, they will be not part of the blue sheet. So please do that. And also, like, I will not use the raise of hand virtually this time. I think that's the what we want, not really raise in hand room. So I think if you log into the system, Net ecosystem, you will be able to register in a blue sheet and also raise hand there. Thanks.
Thank you for the reminder, Zahid. All right, so
I have associated the mapping doc on the data tracker. So
thanks. All right, and now I think we have slides up for Torben, if you would like to unmute and share audio.
Hi, am I audible?
Yes, I can hear you.
Great. All right. Thanks for having invited me, I guess. I'm going to talk about our Panapi system, which is a TAPS-like transport system that we are developing. And there's already been some discussion about this on the mailing list. And Reese was so kind to invite me to give a talk. And here I am. Real quick, although this is not exactly visible, this talk is split into two parts. I'm going to talk a bit about the system that we are building, and then I also have some feedback that might be valuable or might not be. Not sure. So who are we? I'm a PhD student at the NetSys Lab, Network and Distributed Systems Lab at the Otto von Guericke University in Magdeburg, Germany. And our research group is mainly focusing on Psion as a promising future internet architecture. I think many, if not most people here have at least heard about this, but just in case, here's a really quick recap. Psion is a proposed new internet architecture designed to eventually replace BGP. It exposes path awareness and multi-path features to each end host, and it has already seen pretty wide deployment, at least among certain industries. So the financial industry in Switzerland seems pretty keen on it, but internationally there are more deployments. And the project is spearheaded by the network security group of ETH Zurich. Psion has some interesting implications, and so we asked ourselves, what benefit can path awareness actually have on the end host? So the actual user probably doesn't really care. Their internet usually works just fine most of the time, and the average application developer probably also doesn't really care, or rather simply wants to use a high-level networking library and not worry about the rest. As networking nerds, we most likely are the only ones who care, and we would probably be the first to point out that interesting new networking features should not complicate the lives for users, because networking should be a commodity like tap water, right? So it should just work. So if we are interested in rolling out any new features, this has to happen sort of behind the scenes and hidden behind higher level abstractions. And we were very gratified to find that the TAPS community at the IETF seems to agree and hold similar views. So we decided to create a transport services system for Psion, but not only for Psion. And we chose the proposed TAPS API as our front end. In the backend, we have some highly scriptable environment that allows us to experiment with the interesting networking details. And that allows us to try out certain things like different capacity profile based path selection behaviors and so on. We managed to get NGI pointer funding for our system, and we decided to call it Pan API or Panapi for Pathway Networking API, in case our lack of creativity wasn't already obvious. The system is written in Go with a Lua-based scripting backend that supports Lua scripts. It also supports TCP, UDP, and QUIC, as well as UDP and QUIC over Psion. And we have been trying to follow the TAPS architecture as much as possible. But we have made some design decisions that are somewhat departing from the way that things are laid out in the drafts. First of all, we obviously had to add Psion support in a way that is sort of in the spirit of the TAPS spec, although TAPS is very internet specific. We do not use an event system because Go already comes with different native ways to do concurrency properly. We try to have an event system, but this turned out to be highly unintuitive. And since we are, in a sense, developing an API that is meant to be used for the by the average Go programmer that doesn't want to worry too much about networking, we decided to not force an event-based system on them and simply allow them to use idiomatic Go, as it's called. So we avoid the old system of trying and failing by having all calls a block and until they can either return success or an error. If we need asynchronicity, we can simply dispatch these calls in the background as required. The Go primitives are really well suited for this. And we have already had some discussions about the details of this and whether this is in the spirit of TAPS or not on the mailing list. I forgot to link this here, but yeah, the discussion is on record. The second major design decision is that we have chosen to represent the different properties in form of in a strongly typed objects. And this has turned out to be a bit of a nightmare, but more on that later. The idea is that we want to catch mistakes at compile time and avoid errors at runtime, which is in the spirit of our chosen programming environment and language. Yeah, these are the core tenets of our design. I'm happy to receive feedback on this after this presentation, but for now, maybe let's move on. This is an example of code that demonstrates how we are using this, or how we have decided to translate TAPS concepts to our system. You can see that we have mapped some properties to static types. We do ubiquitous error checking. And there's no event system in evidence. Then briefly, we also have a backend that is right now Scion-specific backend daemon. So meaning that for regular non-Scion communication, the API works just fine as a standalone library. And in case there's a daemon present and we are communicating via Scion, there are RPC calls happening between the API library and the daemon. We have support for path quality estimation and scriptable path choice. And optionally, our backend can also perform active latency measurements over certain paths. And we found that most TAPS concepts map pretty directly to Scion, at least in our opinion. So we are quite confident that we are not undermining TAPS semantics in any way. So in the Scion world, different capacity profiles, for instance, can be satisfied by selecting suitable paths after considering cached path performance information, similar to what the standard semantics are. The same is trivially true for different multipath policies, which simply result in message duplication or distribution over different paths. And other properties like session isolation have corresponding semantics. There is at least one thing that we sometimes use in Scion that does not appear to have a TAPS equivalent, which is active probing. Namely something where we perform active pings over alternative paths to a destination and to just keep track of which are available or promise to offer better latency than the currently chosen path. And I would be interested if this is something that could conceivably be added, or if this is something that should stay very much Scion central. So this continues the first part of my talk. I hope everything that I've presented sounded reasonable enough to you. I'd be happy to receive your feedback about and opinions about pitfalls, and both in general and specific. Maybe we can also talk about maybe having a Scion mapping, as Aaron proposed. But I would propose to shift the actual discussion into this to a later point, since I have some feedback of my own.
Yeah, and you have 5 minutes until the end of the session.
Yeah. So there's I previously mentioned that we have had some pain with supporting the different property types in a statically typed way, and so. And with their scope and their validity. So on the left, you see a quote from the API draft, and here the properties are meant as configurable parameters for protocol selection, connections, and messages, and it's all sort of semi-lumped together, but not quite, and sort of they're distinguished. There are certain boundaries which are which could be more explicit, let's say. And on the other hand, on the right-hand side, there's a quote where it says that properties sometimes or at some point have sort of converged and can be queried. So they have converged from a preference to a Boolean. So from an enumerated preference to a Boolean. And the documents do not appear to distinguish between these two stages that the property can be in. It can still be a setting that can be modified and is currently still has not converged, and it can be a converged property that actually reflects the result of a selection process. And we found that this is that when trying to implement this properly, we sort of need to have this clear distinction between the two stages. I think right now the drafts are mentioning that a preference can first be in this sort of preference state, or property can in the preference stage, and then at a later point it congeals, let's say, to a truth value. And this is a very, very, let's say, dynamic way of looking at this. So in dynamically typed programming languages, this is easy, but in statically typed programming languages, this is really hard. And maybe it's worth thinking about how to maybe conceptually distinguish these. The second piece of feedback is a small nitpick. So if you're remembering the discussion from the mailing list, I tried to justify why we didn't use an event-based system, and people were quick to point out that somewhere in an appendix it said that it's valid to implement this in a different way also. And it would have been really nice if this had been clarified way earlier and this went more visibly. So we actually wasted quite some time trying to shoehorn an event-based system into this. Into a Go-centric way. But in conclusion, it has been a pleasure to work with TAPS and the work that you guys have been doing here. And I hope that you guys have interesting comments to what we have done so far. And thanks for listening.
Thank you, Torben. We have Michael in the queue.
Hello, Michael Welzel again. We have been around that block of selection properties morphing into Booleans. I believe that the reason they were unchangeable afterwards is that we didn't have a case of a selection property that would make sense to change afterwards. Like, for instance, you require a reliable transport. You can't change that afterwards.
I don't disagree that properties at some point become immutable. It would just be nice if this was actually sort of if it was a clear distinction between properties that are still mutable and those that aren't.
Yeah, but I believe we didn't have any.
I'd like to ask the remaining speakers to confine your comments to 15 seconds. We're at the end of our time. Let's just try to go quickly. Take it to the mailing list.
So maybe, if there's one concrete case where you think it would make sense to change it afterwards, maybe you can propose text or make a suggestion. But I believe we just didn't have a case.
I see. Okay.
Okay,
Thanks.
let's drain the queue, but we're running into overtime. We have Jake.
Could I just ask you to go back to slide 9 and explain the address passed into the remote endpoint, please?
Yeah, so this is a Scion address. This is the format of a Scion address. The 19 is the isolation domain. The thing that looks a bit like a MAC address is the AS address, and the last part is the AS internal IP address. And the very last part is the port.
Okay, thank you.
Okay, and Brian.
Yeah, so Thorben, you asked a question earlier, does this make sense? Is it in the tap spirit? Yes, this stuff is awesome. Totally okay to not do it event-based, totally okay to do things Go-like. We've actually seen another Go implementation of this that was, I'm just going to throw away all of the naming because it should be called dial because it's Go, right? Like, so this is, I really like how you did this here. Michael addressed your first bit of feedback. Your second bit of feedback has now been filed as issue 1009, and I hope to have a PR for that by the end of the break. So yeah, you're right. We'll fix it. I'm sorry we wasted your time.
You are talking about this thing?
Yeah, the event-driven API stuff. Yeah,
Yeah,
I'm going to fix that right now.
Thanks a lot.
Yeah, and we can also discuss the other one in an issue in a GitHub if we would like.
Yeah, I hesitated to open an issue because it seems like this draft is pretty much mature now, and so I wanted to discuss it first.
No, file an issue if it's if it's too late, it's too late. Issues are cheap and they're easy to close.
Okay,
Right.
thanks. So we are out of time. Aaron, did you have any last words?
Last word is think about whether what other mapping documents might be useful, and send suggestions to the list. So thanks everybody for coming. Great discussion today.
Yeah, thank you everybody. And I think we're gonna have an interim in maybe early May. Let's see.